Alrighty. Okay, what do we have today? Actually, I solved this already, but let's see if I can reproduce an answer. Zero array transformation, part 1. You are given an integer array nums of length n and a 2D array queries. And nums. 2D array queries that have two values, the left and the right. For each query, select a subset indices within the range left to right in nums. Decrement the values of the selected indices by 1. A zero array is an array where all the elements are 0. Return true if it's possible to transform nums into a zero array after processing all queries. Sequentially, otherwise return false. Okay, so you have nums is 1, 0, 1, queries is 0, 2. Decrement the values of the selected indices by 1. Select a subset of indices within range left to right. True. Select a subset of indices of 0 to 2 and decrement the values of those indices by 1. Not. Oh, so specifically, so you're not decrementing 1 within this. Okay, so you're doing this for every query. Select a subset indices within range. Okay. So any number of queries, any number of indices within this query range can be decremented by 1. Okay, 4, 3, 2, 1. 1 through 3, you can decrement those. So this becomes like 4, 2, 1, 0. And then 0, 2, you can decrement that. So it becomes like 4 becomes 3, 2 becomes 1, 1 becomes 0. So it's like 3, 2, no, 3, 1, 3, 1, 0, 0. So it's not a 0 array. Okay. I think I can start by sorting the queries. So let's say let's say n is the number of nums and q is the number of queries. And then what? So if I go through all my queries and kept track of the current decrementing value at that query. So if you have, like, let's say a bunch of queries that are all 0, 2s, right? No, I think I mapped the queries to some decrementing counter. And that decrementing counter denotes how much I can change the query, how much I can change the nums at that index by at most. Okay, so let's say I have a decrementing array, or a decrementing count array, count array, and I need to also map the queries to some change in the decrementing counter. Change in the, okay, actually I'll say decrementing total, and then decrementing change is going to be an array. And what I'm going to do is I'm going to make every query into a tuple that is so actually I don't need to sort the queries quite yet. So for every query, for query and queries, actually, can I make this into A, B? I don't know if this works, but because so an array. Okay, so I guess it does work. So for every, let's say, start and end in the query, I'm going to say the change based on that is going to be recommend change dot append start and then 1, and also end plus 1 negative 1, and then I can sort the changes. So now that I have that, I can figure out the decrementing total. Probably this has a long query list, right? Queries can be 10 to the 5th. Well, in that case, I don't think I need a decrementing total. I just need to keep track of the current change, and I need to go through the decrementing change array while I process the numbers. So let's say current change, say the decrement is currently 0. So for every index in range of the number of numbers, so I can say the value is nums at this index, and I think I need to first figure out what's the total decrement at this index. So while I think I need a second pointer. Dec index 0. So while dec index is less than the length of number of changes, and also, and if it matches the current index, dec index equals, now if the dec change at this index, the index of that matches the current index. Does the queries need to actually, yeah, the queries are within the bounds of the, okay. Is it inclusive? It's inclusive, right? Yeah, within the range left to right, inclusive. So if it matches, then the decrement is going to be changed by the value within dec change that index. And then oops, this is the wrong index. And then I increment the dec index. So then if I have the value is equal to nums at this index, and if the value doesn't match the number of decrements that I can do here, or if the value is bigger than the total decrement that can apply here, then I can't make this 0, so I return false. Otherwise, if I go through all that and it works, then it works. Alright, let's see. Dec change. Need to make sure I have double C's. Dec change is like short for decrement change. Okay, well, it works. Doesn't seem to be very fast compared to what other people are doing. Okay, let's see if we can improve this. So, so there's a sorting that I'm doing. I think maybe the fact that I mean, it's 10 to the 5th. It's 10 to the 5th. Maybe I can just make an array rather than make a tuple here. So if I actually make a change array, so if I make this into an actual, let's say 0 times the length of numbers. So for every start and end queries, I can say the decrement change at the start increases and decrement change at the end. That doesn't seem that fast. Well, maybe it works fine though. Maybe it works fine. So if I do it by that, then I have to sort. And then I can just go through and still, so I don't need to keep track of the decrement index since I know where it is. So I need this while loop here. So for every index in range, I'll say here is the decrement total is changed by the value in my dec change array at this index. And if the value is bigger, if the nums at this index is bigger than decrement, then turn false. Dec change out of bounds because it's inclusive. I see. For some reason, even though it's the right bound index is inclusive of the things that you can change, it's actually, wait, why would that be out? Oh, I see. Yeah. Because then r plus 1 is going to be if r is the last one, then num's that length will be out. So I'm just going to make this n plus 1. It's not going to really affect things all that much. I don't want to make an if statement to check the bounds there. It's just slow. Okay, cool beans. Alright. Do I want to try and make any more improvements? Yeah, it's pretty fast. Guess I really don't need the queue for the number of queries since I just iterate using a for each loop. I think I do need the index. I wonder if this is any faster. Index value. No. Index and range n. Decrement base index there. I don't need a sort. because I'm using a fixed array and modifying that. Fixed decrement change array. Yeah, I think that's good. So summary is going to be so here I basically created an array or create an array to track how much total decrement can be applied at any given. Okay, so actually it's create an array to track where the total decrement that can be applied changes. So it's not necessarily tracking the total decrement, it's checking the total decrement change. So for instance, if you have a bunch of queries that are changing 0 to 2, 0 to 2, 0 to 0 to 2, right? So it's basically stacking the same query. This means that for the 0 index, you're actually being able to decrement by a total of 4. Like each one of these zeros is increasing the decrement change amount that you can do by 4. And that value sticks for falling indices, like at index 1, which is between all these 0, 2s. There you can also decrement the whatever value there is by 4. And it only stops, or that 4 decrement only stops when you're out of the bounds of your query. So technically at 3, index 3, you're decreasing the decrement value that you can do by 1 for every query, right? For each of these 0, 2 queries. So this is what this array does. It's increasing the persistent decrementing value that you can have at the index by 1 at the start of the query, and by decreasing it by 1 after the end of the query. And so because this is a change counter for your decrement value, then for every index as you go through your array, you change your total decrement by that, and then see if that total decrement that you can get is smaller than, or if it's too small, if the value in the nums is too small at the index, then you can't zero it out. So it's going to be false. So decrement changes +1 at start index of each query, and -1 at end index +1 of each query. And it's end index +1 because it's the way that they structured it. The start and end are inclusive, so you apply after. And then what you do, okay, and then go through all indices of nums array, keeping a kind of running total decrement. Apply the change at the decrement change at the index at the start of loop, and check that the total decrement can zero out the value at the index. So by which is if it can't, which is to say that the value is greater than the total decrement. short circuit, return false. After loop, return true. And no impossible value was okay. Time complexity. This is going to be O of n to both generate the O of n, O of q for generating the decrement query, decrement change array based on queries, and O of n O of n yeah, it's O of n to check for impossible zeroing. So overall, this is actually going to be O of q plus n, max of q n. Huh. Wonder what's the difference between q plus n versus max of qn. This thing's runtime is whichever is more, but you do both. So maybe it's q plus n. You always do both. Yeah, I think that seems fair. Okay, space complexity. This can be O of O of n for the array of changes, and the array of changes is based on the number of indices that you have plus 1, so within your nums. Okay. I will note that I did this using my original method, which the original thing I did, which had kind of array of tuples, and changes at indices, was better if n is really large. So for here, I saw that n is between 1 and 10 to the 5th, which is a reasonable size, but it could in theory be much longer. I guess it couldn't be much longer because the array, the nums array has to be 10 to whatever, 10 to that size. But in certain instances where you're creating the kind of decrement array, but the indices are extremely, like, it's not mappable, then you kind of need to do the other method that I did. But in theory, might save you space as well. But whatever.